So we're talking about chemical reactions. And before we get into balancing equations and counting atoms and stuff like that, we're going to start off with this. So I've got two blue color pencils that are tied together, two orange ones, and then two blues and an orange all tied with all three. And so the rules of this, I can't take one of these out, and I can't take another orange one and stick it in there with those three. But I can have as many of these as I want. So if I wanted 3 sets, this is one set, this is a set. If I wanted 3 sets of orange, then I could have 1, 2, 3 sets of orange. We'll see that in a second, but you got to make sure that when we're doing what we're about to go into, you can't start separating these individual things. You can get as many of them or as few as you want, from 1 to 1,000,000, but you can't start separating them. So I'm just going to write down what we've got. In this little demonstration, we've got 2 blues coming together with 2 oranges, making a blue and an orange. So something should jump out at you as a problem, but we'll get to that in a second. So we've got we've got orange and blue. So I do it right below the arrow. And so how many blues are on the left side? So with blues, we've got 1, 2 blues. And oranges, we've got 2 oranges on the left side, 1, 2. On the right side, we've got 1, 2 blues, and oranges, we've got 1. So something should have jumped out at you. We started off with 2 blues, ended up with 2 blues, started out with 2 oranges, and ended up with 1 orange. And because we talk about the law of conservation of mass, the law of conservation of mass is that matter can neither be created nor destroyed. And it looks as if something was created or destroyed here because we started off with 2 and we ended up with 1 orange. So what we are able to do again is we can change how many of these. So let's add another one over here. So now I don't know if you can see it, but we've got 2 of the same exact molecule, 2 blues and an orange, 2 blues and an orange. So we got to reassess how many. So the blues over here, we've got 1, 2, 3, 4. And oranges, now we have 1, 2. Hey, our orange problem is fixed, but now we have a blue problem. So we come over here, and so we've got 4 on the right side and 2 on the left side. We're going to add here because we're not going to take away stuff. We can't just start pulling, 1 blue out of each of these molecules. So what we're going to do is we're going to add, another blue. Now we've got 4. We've got 1, 2, 3, 4. So we've got 4 blues on the left, 4 blues on the right, 2 oranges on the left, 2 oranges on the right. This one is balanced. And that is essentially what we're going to do. Now we're going to do it with molecules and not just random classroom supplies. So with molecules, what this would look like is we've got H2 and O2 giving us H2O. I'll put a little plus sign here. So, sorry for the view. I know it's a little odd, but we've got H's and O's. On the left side, how many hydrogens do we have? H2 is telling us that there is an H connected to an H. O2 is telling us there's an O connected to an O. And H2O is saying there's 2 hydrogens, 1 oxygen, and that one doesn't have to be there, but it's assumed. So on the left, we have 2 hydrogens and 2 oxygens, 1, 2. And over here, we have 2 hydrogens and 1 oxygen. So we've got a similar problem. Now we've got to say, all right, how many of these water molecules? Let's add another water molecule. So we'll put a 2 here. And we're going to mark through these because these are no longer accurate. Now let's count these again. If 1 molecule of H2O has 2 hydrogens, and now I'm saying there's 2 water molecules, then that means there's going to be 4. There's 2 originally, and if I have 2 of them, it's times 2. It's going to be 4. There's 4 hydrogens, 2 times 2. And 2 times 1 is going to be 2. We can see that if we drew another one of these. Putting a 2 here made us go from just 1. Now there's 2. This is a water molecule. This is a water molecule. And we can count them. There's 2 hydrogens in each. There's one oxygen in each, 2 hydrogens, 1 oxygen. So now that there's 2, we've fixed that, but again, we have another problem. We've got a hydrogen problem. There's more on this side, and we're not going to take away, we're going to add some here. So there's a 1 right here now. Let's add a 2. So there's 2 hydrogens. If you wanted to draw again, you've got to learn the shortcut because drawing these molecules is going to get very old very quick. But because there's 2 hydrogen molecules, this is 1 molecule, there's 2 of these. 1, 2, there's 4. 2 times 2. There's going to be 4 hydrogens. 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right. And that's how we balance chemical equations. If it helps to think of this, of actual objects that you cannot take apart, you cannot just take oxygen apart from the water molecule or something similar, or make this an O3. We're not doing that. You can't do that. So I hope this helps in balancing chemical reaction formulas or chemical formulas.